Good day, future scientists, teachers, engineers. Today, your chemistry lesson is about the properties of saturated and unsaturated solution. Good day, everyone. I am Valenciano. I am a chemical engineer by profession and also a student of CTP Nova Scola who will take you through the journey of exploring the topics for today. I was also once a student like you who was curious about how things work. So, come on. I know you got the same feeling. Fasten your seatbelt and let's start this journey of learning in the chemistry world. Oops! Before we take our journey, some words of wisdom from Rohit Paul he's sharing with us. He said, life is chemistry. Dilute your sorrow. Evaporate your worries. Filter your mistake. Boil your ego. And you will get the crystal of happiness. Chemistry is not just on books. Chemistry is all around us, and using these scientific terminologies in views and opinions about one's life is cool. There will be four main divisions of the topics. Number one is lesson objectives. Number two, topics recall. Number three, saturated and unsaturated solutions. Last but not the least, number four, recap. Note to watch out for the colored terms for emphasis in learning. Topic number one, lesson objectives. These are the things you should learn at the end of this journey. There are three lesson objectives on this learning session. You can also notice that there are three highlighted words which are critical for you to understand. The first objective is that you will determine that solutions can either be saturated or unsaturated. The highlighted word there is to determine. This means at the end of the session, you should have learned about the categories of solution if it is saturated or unsaturated. The next objective is that you will get familiarized with the terms describing the properties of solutions. The highlighted word in yellow there is familiarized. It means you will be able to get aware of all the scientific terms about properties of solution. Isn't it cool? Well, last but not the least is that you will learn to investigate properties of saturated and unsaturated solution. The highlighted word there is investigate, which is a very important activity that scientists, teachers, and engineers are always on the go for anything out of their curiosity. It is the first step to understand something when you are interested to investigate. Now, are you ready to start the learning too? Let's go! Number two, topics recall. So that we will have a smooth learning journey, it is important for us to do some recall of the topics and terminologies covered in previous section. We learned that matter is anything that occupies space, has volume and mass. Matter is further categorized into two, pure substances and mixtures. Pure substance is a form of matter that has constant chemical composition and characteristic properties, while a mixture refers to the physical combination of two or more substances in which the identities of the individual substances are retained. Under pure substances, there are elements and compounds. An element is a chemical substance that is made up of a particular kind of atom and hence cannot be broken down or transformed by a chemical reaction into different elements, while a compound is a chemical substance that is composed of a particular set of molecules or ions that are chemically bonded. Under mixture, we have two subcategories: homogeneous and heterogeneous. Homogeneous mixture is a mixture of two or more chemical substances, whether elements or compounds, where the different components cannot be visually distinguished, while a heterogeneous mixture is a mixture of two or more chemical substances, whether elements or compounds, where the different components can be visually distinguished and easily separated by physical means. Again, take note of the yellow highlighted items. From previous basic concepts recall, we have matter, composed of pure substances and mixtures. Under pure substances, we have elements and compounds. Example of elements are oxygen, chlorine, and sodium. Example of compounds are water, or H2O, salt, or sodium chloride, and sugar, or C12H22O11. Under mixture, examples of homogeneous mixtures are air, salt dissolved in water, or sugar dissolved in water. Example of heterogeneous mixtures are sand, oil and water, and orange juice with pulp. Now that we already understand how all of these are related to each other, we will focus on the subcategory of homogeneous mixture, which is the solution. Now that we have learned about the homogeneous solution from previous slide, I will now introduce you to the term solution. A solution is a homogeneous mixture in any phase in which the minor component or the solute is uniformly distributed within the major component or the solvent. The components of solution are solute, which is the substance being dissolved, and the solvent, or the dissolving agent where the solute is being dissolved. Now that we have learned that solution is a homogeneous mixture, for us to understand this better, let me pick one of the examples of a solution, which is air. Air is actually a gas solution in which you are very familiar with. Air is a mixture of gases which forms the Earth's atmosphere and which we breathe and airplanes fly too. Since air is a solution, it has its solute and solvent. Do you know that the solute is composed of a lot of substances such as oxygen, carbon dioxide, argon, water vapor, and other gases? The largest amount in air is nitrogen, making it the solvent. Amazing! It has a lot of components but you cannot visually see air and you cannot even see its substances. Of course, if it is a homogeneous solution of the solute and solvent, that is why you cannot see them separately. Cool! However, when some components such as solute becomes too high in amount, the property of the solution changes. One example is our problem about air with pollution, or simply air pollution. Do you know that air pollution occurs when certain amounts of solute like contaminants as you see in red font, composed of NOx or nitrous oxides, SOx or sulfur oxides, CO or carbon monoxide, soot and dust become too high. When this happens, you feel uneasy to breathe this condition of air. Unfortunately, many of highly progressive cities, like our Metro Manila as you can see in the background picture, suffer from air pollution due to high volumes of contamination from factories, cars, buses, and other modes of transportation. These are results of excessive human activity. Are there ways to solve this big problem? Hmm. Well, scientists and engineers have thought of ways to solve this air pollution problem by understanding the properties of the solution and its components as solute and solvent of a polluted air. We have learned that air is a solution in a gaseous form. What makes air polluted is the part of its solute, which are the contaminants. Now, since the solute and solvent have varying or different properties, while controlling the temperature, a polluted air can then be liquefied. This means that by lowering significantly the temperature of the air, a gas can change its phase to liquid form, and this is called liquefaction. When the air is already in liquid form as a solution, it goes to a next process, as you can see in the diagram, called distillation. This is where solute and solvent components, which include the contaminants, are separated by increasing temperature so that light materials can be separated from heavy materials because of its different boiling points. By then, you can separate those components and remove the contaminants. This somehow can be a first step to resolve a bigger issue of air pollution. It is amazing that indeed, by learning the basics of science, such as the properties of the solution, you can actually make a significant change in the world. Who knows? One of you can further develop this technology and eventually end our problem in air pollution. Part 3: Saturated and Unsaturated Solutions. So, we have previously learned that these are the components of the solute in air, emphasizing that the presence of contaminants in the air solution and its amount results to a different condition and properties of air. For instance, when these contaminants become higher, it will result to a higher content of these contaminants in air as pollutants. Then we can say that the air is saturated with pollutants, hence air pollution. Now in opposite, once the solute as contaminants becomes lower, it will result to unsaturated air or clean air, the air that we want to breathe in. Indeed, this is chemistry at work around us. Now, for us to understand this further, let's take our common table salt, or asin, in Tagalog. The common table salt is known in chemistry world as sodium chloride, which is ionically bonded as a result of reaction between a sodium or metal cation or positive ion and chloride, a non-metal anion or negative ion. This forms a crystalline structure of sodium chloride or the table salt, the asin that makes our food tasty. Now, let's see what happens when sodium chloride or salt is dissolved in water. Let's watch the video on the next slide.
Let's add a small amount of table salt, sodium chloride, to water. As you know, sodium chloride dissolves in water. Click on the Zoom button to view sodium chloride dissolving in water on a microscopic scale. Polar water molecules interact with the positive and negative ions of a salt. The positive ends of the water molecules are attracted to the negative chloride ions. The negative ends of the water molecules are attracted to the positive sodium ions. This interaction between water and the salt ions causes a salt to break apart or dissolve in water.
Now, what happens when you dissolve salt in water? Eureka! You formed a solution of salt in water. Microscopically, solvent molecules are attracted to surface ions of the solute. Each solute ion is then surrounded by solvent molecules. Now, as scientists, let's make some assumption. What if we continue to add more salt to the solution? For this instance, what will happen? Hmm. When this happens, you are expected to form a saturated solution of salt in water. How does this happen? This happens as most of the water molecule in the solution is already bonded with either sodium or chloride ions. Anything that will be in excess of the capacity of the solution in water to dissolve additional salt will not be anymore dissolved, as you can see in the diagram. In this case, you already achieved the saturation point. Hence, recalling that information, adding more science to it, more specific, at 20 degrees Celsius of temperature, the maximum amount of sodium chloride or salt that will dissolve in 100 grams or 100 ml of water is only 36 grams. If you add more of this in the solution, say you add additional 4 grams of sodium chloride on top of the 36 grams, it will remain undissolved. Hence, any amount exceeding 36 grams of sodium chloride to be dissolved in 100 grams or 100 ml of water will remain undissolved. This means that the saturation point of salt solution in water is 36 grams of sodium chloride in 100 grams or 100 ml of water at 20 degrees Celsius.
Let us now do another workout. Take a beaker and dissolve some amount of salt in it. Go on adding salt to the solution. As long as the salt is dissolved in water, the solution is an unsaturated solution. But a stage will soon come when you will not be able to dissolve more salt in the solution. At this stage, the solution becomes saturated. Thus, a solution is said to be saturated if it cannot dissolve any more quantity of the given substance in it.
So, what if we achieve a saturated solution? Why is it that additional salt cannot be dissolved anymore? There are two main reasons for that. The first one is that this happens when the solute ions like sodium and chloride are mostly hydrated and bonded by water molecule. Hydration happens when the solute are mostly bonded with water molecule present. The second reason for this phenomenon is that some of the dissolved solute ions like sodium and chloride collide back again with the crystalline remainder, thus making this crystal undissolved. The phenomenon that we had just described earlier is called recrystallization. It is the process of dissolved solute, such as sodium or chloride ions, returning to the solid state in the solution. Now, when the two described phenomenon occur at the same time and almost at the same rate, the solution is said to be at equilibrium. Equilibrium is a word pertaining to a state of balance. Hence, on our example, if the two reactions or two processes are occurring are almost at the same rate, say for instance, the process of hydration of the solute occurring at the same time with recrystallization process, the solution is said to be in equilibrium. And believe me guys, this physical state are opposing process, especially occurring in a saturated solution, but they can occur at the same rate when the solution is at equilibrium. This is designated by the double arrowhead in the reaction of sodium chloride dissociation to sodium ion and chloride ion in aqueous solution. Saturated solutions are all around us. Aside from table salt in solution, we can also observe this when carbon dioxide in soda solution or soft drinks appears to be escaping out as shown in the first image. Or when you try to put more chocolate powder to a hot water and milk in such a way that you notice that some powder are just floating and not being dissolved, even if you stir it enough. On is something that we cannot see, but it's crucial to the life of all organisms, including us humans, is that we may not be aware that our soil and atmosphere are also saturated with all forms of nitrogen compounds essential to all life-sustaining reactions such as those occurring in plants. There are critical processes which only will work when the solution is saturated in nature. Saturated solution, how important it is. Cool! Part 4. Recap. Let's make a recap on what we have learned. We have learned that a saturated solution is a solution which cannot dissolve any more quantity of a given substance in it. Also, we also know that unsaturated solution is a solution which can dissolve more quantity of a given substance in it. And lastly, a saturated solution containing the maximum amount of solute cannot further dissolve any additional solute. What are the other learnings? We have learned about the phenomenon on the solution equilibrium, which is the physical state described by the opposing processes of dissolution and recrystallization occurring at the same rate. Also, the phenomenon of recrystallization, which is the process of dissolved solutes returning to the solid state in the solution. And of course, we have realized that we are surrounded by various examples of saturated solutions in our daily lives. The chemistry of solution starts with understanding the basics of saturation and equilibrium, and there are a lot more phenomena present in solution which you will learn as you go through with the learning journey. As future scientists and engineers, educators, you will also play a vital part in the society to make science and technology valuable. Who knows? We can continuously clean the air by liquefaction, and we will have a better earth to live in. As future scientist, engineer, or educator, be like a pinch of salt. Hi guys! Again, I am Valenciano and thank you so much for your attention. I hope you enjoyed our learning experience in exploring the topics for today in the chemistry world. Take care everyone and see you again next time. Bye-bye! Guys, it's time for learning assessment. Please prepare a pen and paper to write your answers. For this set of questions, you have 3 minutes. Can you determine whether the following statements are true or false? Five seconds. Time is up. Here are the answers. I hope you get them all correctly. Last but not the least, you have approximately 30 seconds. Can you determine which of the following pictures are saturated solution? 5 seconds. Time is up. All of them are saturated solution. Good job, you guys! This is the end of the assessment. Thank you, guys.